Welcome to our lesson on graphing inequalities. Our learning targets for this lesson are to be able to graph our linear inequalities, and these will be graphing not just on a number line but actually in the coordinate plane, and we will also be graphing absolute value inequalities. So first of all, a linear inequality, it's very similar to a line or an equation, but we have an inequality sign. So we're going to have regions that are shaded instead of just a line. The line will serve as a boundary, and then we will have to do a test point to decide which side of the line will be shaded. And a couple of pieces of information for you. I've got an example for you on this slide where we have y is less than or equal to 2x plus 1 is our inequality. The boundary line is the equation y equals 2x plus 1. And so we need to do a little review of how to graph lines. Well, one of the ways that you can graph a line is by using the y-intercept and the slope. So you could plot the y-intercept and then use the slope of positive 2, which would be up 2, right 1. So it'd be like 2 over 1. Another way of graphing our lines is to go ahead and use the intercepts, the x and y intercepts. So you can choose which method you want to use. You could also do an xy table or chart and just plot points to find your line as well. So once you have an idea of what that boundary looks like, then we have to decide whether or not it will be a solid line or a dotted line. So as long as our inequality has the equal to with it, if it's less than or equal to or greater than or equal to, it's a solid line because any point on that line is part of our solution. Now if we just have a greater than or a less than and there is no equal to, then that boundary line is dotted. Okay, and so we'll look at some examples where we'll have each of those, and then we need to use a test point to figure out which side we shade. And the test point we're usually going to use is the origin. So here's an example. We are to graph the equation, or excuse me, the inequality. 2x plus 3y is greater than 6. So the boundary is just the graph of the line 2x plus 3y equals 6. And since our inequality is a greater than, that tells us that the boundary is going to be dashed or dotted. It's not solid, so make sure you give it a dashed line. And then we're always going to test the point 0, 0, the origin. So to test that point, we put in 0 for x and for y, and that gives us a value of 0 being greater than 6. Now 0 is not greater than 6, so that's false. So 0, 0 is not part of our solution. So we want to shade the side of the boundary opposite 0, 0, where 0, 0 is not part of the solution. Okay, so wherever that boundary is, we want to shade the region opposite that. Okay, it does not contain that. So I think for graphing this, I would just graph using the intercepts. So if you let x be 0, then y would be 2. If you let y be 0, x would be 3. And once you had those 2 points, you could connect them and a dotted line. So here's the point 3, 0 and the point 0, 2. Once you had those 2 points, draw your dotted line. We said 0, 0 is not a solution, so we want to shade the opposite side of the line as that side that contains 0, 0. So to graph an absolute value inequality, very similar to graphing just our regular linear inequalities, the one thing that you should know or be aware of is that all absolute value graphs are V's. They're in a V-shaped. So you just have to figure out where that vertex is and what way it opens up or down and so on and so forth. So in this inequality, our inequality symbol is less than. So that tells us the boundary is dashed. We need to graph the equation y equals x plus 1 without the absolute value. And that's only going to be part of our graph. We really need to figure out where that vertex is, and then we'll test the point 0, 0. So I think the best way to do this one, we know that if we let x be 0, y is going to be 1. So we know that our y-intercept will be 0, 1. So we could graph that point. And we really only need a couple of other values. I went ahead and filled out a table with some x and y values. If we plug in either positive 2 or negative 2 into this, The absolute value of both of those is positive 2, and 2 plus 1 is 3. So either of those values gives us an output of 3. If we plug in either a plus or a minus 1, we get out a positive 1, so that would give us a value of 2. Well, here I've got 5 different points. If we go ahead and plot those points, we can get a pretty good idea of what that looks like. And testing our origin value, 0 less than the absolute value of 0 plus 1. Is 0 less than 1? That is a true statement, so we want to shade the region that contains the origin, or that includes the origin. And here's a picture of what your graph looks like. So 0, 1 is the vertex of that thing. We want the side shaded that includes the origin, which is all of the area below where our graph boundaries are. Notice we have dotted or dashed lines. So sometimes you might want to use intercepts, sometimes you might want to use a table, sometimes you might want to use your slope and your y-intercept. So here are 2 problems for you to try on your own. Problem 1, I would probably graph that using the intercepts. That would be a pretty quick and efficient way to do that. Don't forget to do your test point and do your shading. So it's not just a line. You want a shaded region. Over on the right hand side for number 2, that one I would pick some values for x and figure out what your output values are for y. So that'll do it for this video. We'll see you next time.